So hello, everyone. My name is Margot Gia, and I'm with the Windham Regional Commission. And we're very excited to be able to welcome you tonight to hear a little bit about the water quality of the Deerfield, the North Branch of the Deerfield River, as well as Beaver Brook. Thank you, Ryan. And we are really excited to welcome Ryan O'Donnell, who is with the Deerfield River Watershed Alliance, the DRWA
Association.
Association. I do this every time. So the DRWA, he is also with the Connecticut River Conservancy, and under both of those organizations, he is in charge of the monitoring programs that happen throughout southeastern Vermont. So we're really excited to welcome him tonight. As he's going through his presentation, if you have questions that are sort of clarifying about maybe what he's presenting at that moment, please feel free to jump in to ask that question. If it's more of a discussion type question, we're going to hold those off to the end so that Ryan has a chance to get through the whole presentation first. So if during the presentation, if everyone could keep their mics on mute, that would just help reduce background noises. And I think I will pass this over to Ryan. So Ryan?
Great. So thanks for coming. And let me share my screen. So I am reviewing all the water quality data we have from the North Branch Deerfield River Watershed, which includes the Beaver Brook and a couple of other tributaries. And this program started, this iteration of water quality monitoring in the Deerfield watershed started in 2017. So this is all the data we've collected over the years, and trying to look at it a few different ways and learn some things about the water quality. And yeah. So I always like to start at the beginning with what is a watershed. So a watershed is an area of land that drains to a particular body of water. And what's really important is that everything that's happening on the land in this diagram, you know, we have a city and a farm and a horse. All the stuff that happens on the land affects the water quality, because as it rains or as it snows and then melts, the water picks up things from the land and brings it to the water in it. And then a tributary is depicted in this little section right here, where you have, you know, a smaller river that's moving to a bigger river. And then of course all of these rivers and their tributaries drain to this ocean or lake or whatever it is. So for what affects water quality, I just told you the things that happen on the land, and land use is the primary driver of water quality. And so the graph on the left shows the how water moves across the landscape based on different land uses. So if we start the furthest left, we have forest, you know, which if New England were left alone, it would be primarily forested. And the different colors talk about the different kinds of water. So the browns are groundwater, whether it's shallow or deep. And then the blue is evapotranspiration. Evapotranspiration is the combination of water that evaporates and transpirates, which means it was picked up by plants and then used and released into the atmosphere. And so in a forested landscape, all of the water that falls on, you know, all the rain or snow that melts would be either infiltrated into the ground or picked up by the trees or just evaporated directly into the atmosphere. When you start disturbing the land a little, and you might move to pasture, so you've removed the trees, but you still have primarily grass, you start to see more shallow groundwater and a little bit less evapotranspiration. There just aren't those big plants anymore to pick up the water. And you get this tiny introduction of this red line, which is surface runoff. Surface runoff is water that hits the land and goes straight into the nearest lake, pond, river, stream. If you then move to like a suburban type land use where you have houses and a lot of pavement, but you still have a lot of grass and trees, so you have a mix, you're getting almost no deep groundwater flow, but you are still having a significant amount of shallow groundwater, less evapotranspiration, and you're starting to see more and more runoff. And then if you move into a city, which is a primarily paved, we call those impervious surfaces. They're impervious to water infiltrating into them. You end up with almost entirely surface runoff and a little bit of evapotranspiration, mostly evaporation. And the thing is that this surface runoff has no chance to be filtered. And so it's bringing whatever it picks up with it while it's traveling over the land directly to that water body. The other thing we see with a change in land use is how much and how quickly the water flows. So on the right, we see, don't worry about all the words. The lines are the most important part. So you have this black line with a light blue filling. That's rainfall. So you have a period of rainfall, and the pink line shows you how an undeveloped watershed would react. You'd have a slow increase to a peak and then a slow decrease. However, when you start increasing the amount of impervious surfaces, there's no route for that water to slowly trickle through the ground to get to the stream after it rains. And so it kind of just all goes straight there. You're not having trees pick it up and slow it down on its way by. And so what you see is a quicker increase in the water and also a higher peak. And so you see the stream fill up faster with more water and then empty faster back down to base flow. And so we call that being more flashy, like a flash flood. And that can have also effects on water quality, because those sudden changes in flow can affect things like erosion. So looking at the North Branch Deerfield watershed, here's a map of just on top of like a Google base map. I figure we're all pretty used to looking at Google Maps in this day and age. And you can see the main stem goes by Mount Snow through Dover, down through West Dover, and then follows Route 100 into Wilmington, through there. And then we also I have highlighted Cold Brook because we monitored that when we first started the program. We also monitor Ellis Brook, which flows through Dover, and then Beaver Brook, which flows down along Route 9 and meets the North Branch in the center of Wilmington. And there are definitely some other tributaries that maybe we'll monitor in the future. And so here we have a satellite, so you can kind of see the different land uses, mostly green, which is good, but you can see farm fields and you can see these ski trails up by Mount Snow. And here's the different water quality monitoring sites, and I'm vaguely color coded to help you tell which stream is which. So the green ones are the North Branch of the Deerfield, and we sample upstream of Mount Snow, near the Valley Trail trailhead, downstream of Mount Snow and some of Dover. Then we sample off of East Dover Road. I can't think of a good landmark to explain that. Ellis Brook is light blue. We sampled the Cold Brook near the mouth for a while on yellow. We sampled, I don't think it's called this anymore, but it was called Mountain Marketplace off of Route 100. We sampled behind there, and I think it's a different farm stand now, but we haven't sampled there in a couple of years. And then we've sampled in Wilmington Center, mostly downstream of the confluence with Beaver Brook, but we did monitor a couple of years upstream. And then we've sampled Beaver Brook off of Route 9, kind of behind Wahoo's, not kind of, behind Wahoo's. And then we 1 year sampled this tiny tributary off of Shearer Hill Road, because there was a landowner who was interested and was concerned that the runoff coming across her property from the hill was affecting water quality. So the nearest stream gauge is actually the Green River in Coleraine is the nearest stream gauge that's not on a dammed river. And so this is just a look at the stream flow over the 6 years included in this presentation. And we break down our flows into low, moderate, and high. Low is the bottom 25% of flows ever recorded. High is the highest 25%, and moderate's everything in between. But I also like to show the stream flow because one of the things that's really challenging is comparing year to year, because so much is affected by how much water is in the stream when you're sampling. So 2021, we had some really, really high flows, and you can see there's some big peaks in here, but we also have lots of really low flows. And of course, we're only sampling 6 to 8 times a season. And sometimes the schedule, it could be a really rainy year, but for some reason it never rains on Wednesdays when you're sampling. This is the same data, but with a logarithmic scale, which kind of makes the highs more compact and spreads the lows out. And you can see, we all know that it's been some really low flows the past few years. You can see these really, really low numbers. And so, a full range of flows is captured during this time period. So the first parameter I'm going to talk about, and which is probably the most visible parameter that we monitor for, is E. coli bacteria. And it's visible, I mean, that you're most likely to come into contact with the results because we put them out there widely. So we use E. coli bacteria to determine the level of risk for recreation. So that's swimming, boating, fishing, tubing, anything where you're having fun in the water. Primary contact, we usually shorthand this as swimming, something that you're coming in full contact with the water. The EPA and all the states have set a recommendation to not recreate in waters with greater than 235 organisms per 100 milliliters of water. Secondary contact, which is boating, jet skiing, something where you're not in the water, but you might get sprayed in the face with the water. You might accidentally ingest some water, but it's less likely. We have set, the EPA has set at 625. I only use that primary contact recreation because these are small rivers. No, hopefully no one's out. I mean, you might be paddling some of the north branch of the Deerfield, but it's pretty shallow. It's an indicator organism, which means that in addition to testing for the E. coli bacteria itself, which is found in the guts of all warm-blooded animals, it's an indicator of fecal contamination in the water. But having fecal contamination means that there's many other things that could be in the water making you sick. But E. coli is very easy to test for. And the sources include agricultural and urban runoff, failing septic systems, leaking sewer pipes, pet waste, wildlife waste, etc. And we see increased levels after rainfall. So this is a stream profile. So the numbers across the bottom are the river miles. And so this is the E. coli by year and weather. So when we do our testing, we marked down whether it was wet or dry weather, and wet weather is greater than 1/10 of an inch in the 24 hours prior to sampling. And that means that there was likely runoff, like I mentioned before. And usually when we look at these graphs, the dry is way lower than the wet. But especially in 2019, we had really high bacteria levels all, through Wilmington. So the last dot on all of these is the center of Wilmington, behind the shops in that parking lot where you can get to the river. And so we see kind of consistently elevated E. coli bacteria there, and upstream, is looking a little better. I don't know why or what happened in 2019 that was particularly high. I don't remember being able to find a cause for that. But here's the tributaries. There's only one sign on each of the tributaries, so you can't put it in a nice line showing the profile in the same way. And the different colors are the different years. So as you can see, we've sampled different places on different years, but we've been sampling Beaver Brook pretty consistently ever since 2018, because starting in 2017, we saw those high bacteria levels and wanted to know, is Beaver Brook the source? And we do see elevated E. coli in rain, not as much when it's dry, although you can see in 2020, we did have some high levels. And when we sampled upstream and downstream of Beaver Brook, it did seem there did seem to be some influence from Beaver Brook, but not consistently. So we don't think that the source of E. coli is primarily Beaver Brook. The tributary actually had really high E. coli in dry weather, which was interesting, and less E. coli during wet weather. So it's probably a little warm and soupy, just a perfect breeding ground for bacteria. And then Cold Brook was very low bacteria, wet or dry, which we like to see. So that was by just wet or dry weather, but we also have all our results categorized by flow. And so we have red is low flow, green is moderate flow, and blue is high flow. And what's interesting is that low and moderates, especially for bacteria, can include both wet and dry weather, where high flow is almost always is almost always wet weather, because that's why there's so much water in the river. And this is pretty typical that we see, moderate is the biggest range, and that we see actually slightly less bacteria during high flows, because the water there's just so much water, it's pretty diluted. Nothing stands out to me about any of these graphs, showing the same thing, that the E. coli tends to be higher as you move towards Wilmington Center, and that one year we had really high E. coli at the Mountain Marketplace, and then like the next year we had really low bacteria there. So same thing, kind of low, pretty good in the tributaries, though we do see, higher bacteria from Beaver Brook in high flows. And then I just threw everything into my program and said, are there any trends here? And there's, these lines are all over the place. So I'm going to confidently say, no, there's not really any trends of the bacteria. If they were all going up or they were all going down, I would feel more confident in saying something. But that's the question that I always get asked. And these are only low flow, dry weather, because we figure those are the most consistent, way to compare across years, because if you try to compare years as a whole, what you're really looking at is how wet and how much water was in the river each year. So here, all things equal, there doesn't seem to be many trends. Moving on to total nitrogen. Nitrogen is a nutrient affecting plant growth. It is the controlling nutrient in saltwater ecosystems, which is important to us because the water from this area, goes into the Deerfield, goes into the Connecticut River, which ends up eventually in Long Island Sound, which has too much nitrogen in it. And so the Connecticut River Conservancy is very concerned about nitrogen levels throughout the entire watershed. So this and too much nitrogen can result in an overgrowth of algae called eutrophication, and that can lead to decreased sunlight, which causes plants to die off, and then they decompose and aren't producing oxygen, and so you end up with really low oxygen levels in Long Island Sound. Total nitrogen counts all forms of nitrogen, so that includes nitrates, nitrites, ammonia, and it just kind of lumps them all together. The sources for nitrogen are agricultural runoff, wastewater. Most wastewater treatment plants currently do not remove nitrogen as part of their treatment process, although we'll expect to see that more in the future. Failing septic systems can also be a big source. And what's interesting about nitrogen is it's very mobile. It really enjoys being dissolved in water. It dissolves very easily. And so we see that these numbers are tend to be less affected by rain. And then here's my little cows helping you understand the nitrogen cycle. So once again, looking at the profile of the north branch of the Deerfield, most of the nitrogen graphs that I look at, when I break them into wet and dry, the wet is actually way lower than the dry. And this is less true in the north branch of the Deerfield. And it's particularly interesting to me to see that there was some significant nitrogen moving during wet weather, particularly this past year. But overall, this line is a suggestion by the EPA based on the region. It's not any sort of legal threshold. It's what would be ideal for sending water down to Long Island Sound. But these are well within the Vermont standard for nitrogen, which is way up there. Maybe too far up there, but so this is a borderline high, I would say, at times. Looking at the same kind of data for the tributaries, you see everything is mostly below the line, but except for Ellis Brook during wet weather, is elevated compared to dry weather. And like I said, normally we see nitrogen as and actually Beaver Brook too. So often we see nitrogen get diluted in wet weather. And here we can see that there seems to be some significant wet weather sources. And this Ellis Brook site is actually downstream of that wastewater treatment facility that they're upgrading. So that's part of why we're monitoring it, so that the state can keep an eye on how that process is going. And so we like to help with that. Here we look at the same thing, but by flow level. And you can see that moderate flows tend to be diluted compared to low flows. And then those high flows are maybe, especially in the headwaters, picking up more nitrogen, which might make sense. They're picking up sediment, they're picking up plants, those things could get included in there. And you see this pattern, but you can see Ellis Brook, can have some higher levels compared to these other things, but also remember that it's very small. So yeah, it's carrying less nitrogen overall. So it'll be interesting to see this moving forward. I would just also say that it kind of seems to, the headwaters is pretty low, and then it seems to stay pretty consistent moving downstream. Once again, put these on a graph. I don't see maybe a decreasing trend sometime in some of the spots, but overall, not a lot of trends. The truth is that, you know, unless you're actively changing something, I don't think that we would see any trends, but that's the question that that I get asked the most often is like, how's it doing over time? And unless you're doing some sort of restoration project, or someone has suddenly started polluting in a new way, we probably wouldn't see any trends. Looking at phosphorus, it is the other nutrient that we monitor that is affecting plant growth, and it's the controlling nutrient in freshwater ecosystems. So as Vermonters, you probably hear a lot about phosphorus in relation to Lake Champlain. And that's because it's freshwater, and too much phosphorus leads to that eutrophication that I was talking about before, but in freshwater. I will say that as the waters are warming, with the climate warming, we are starting to see more harmful algal blooms caused probably by warm water and increased nutrients, phosphorus, in Massachusetts and some in Vermont too, I think. So we're seeing those more frequently, and we didn't used to see those on, especially in rivers, as much. So those low flow areas, we're starting to see these algal blooms a little bit more. So definitely want to keep an eye on the phosphorus. Once again, total means it counts all forms: organic, inorganic, dissolved, suspended. Similar sources to nitrogen, agricultural runoff, wastewater, failing septic systems. And phosphorus, in comparison to nitrogen, is very sticky. The water quality monitors, actually, everything else is collected in a plastic bottle, but we have to use a glass bottle for nitrogen or for phosphorus to make sure that, because it sticks less to the glass and it's easier to get the phosphorus back out when you're testing it. And so because it's so sticky, it likes to stick to sediment. And so we see that the levels are really related to rain in a way similar to the way E. coli is. But this more has to do with the turbidity of the sediment getting stirred up and carrying that phosphorus with it. So here you can see that in dry weather, we're below the state standard for cold water pretty consistently. And then in wet weather, you can really get a lot of phosphorus moving through the system. And you can, I mean, we've all seen the river when it's very full of water and it's just brown running chocolate milk, and all of that brown has a lot of phosphorus in it. So, you know, that's very common across Vermont. So the North Branch Deerfield doesn't stand out particularly. But once again, like just that slug of phosphorus is moving downstream. And it's not always, as you can see. 2021 was a particularly muddy year, I think. Looking at the tributaries, you can see, once again, 2021. So this is downstream of where Beaver Brook comes in. And then if you look at the 2021 wet weather, you see the Beaver Brook maybe had a lot of sediment moving downstream and bringing a lot of phosphorus to the North Branch of the Deerfield. Everywhere else looks, the Beaver Brook tributary, Cold Brook was pretty low, but occasionally occasionally high in wet weather. And then Ellis Brook, sorry, I was just trying to remember why we have one 2017 thing, and I think it was that someone had asked me to collect a sample on Cold Brook to see if we should be monitoring it for phosphorus. And then Ellis Brook, you know, we can see that it's very low in dry weather, but in wet weather, it's moving a lot of phosphorus, especially in 2021. And so I can't speak on whether or not that has to do with the wastewater treatment plant upgrade or anything like that, but it is something that we'll approach with our state partners to discuss. As you can see, Ellis Brook in that high flow is really skewing this graph. So I just wanted to show you, there's a couple of really high numbers, and that happens sometimes, but I took those high numbers out. Well, I readjusted the graph. So I took those high numbers out, and you can see a little bit more of what it looks like. And you can see high or moderate flows are moving a lot of phosphorus at times, and low flows tend to be pretty good below the standard. The Beaver Brook trib tended to be a little high. Beaver Brook is probably above the standard consistently. So we may want to look into more potential sources to Beaver Brook in particular. Cold Brook looks good. And then we've already discussed Ellis Brook. It does look like Beaver Brook has an increasing trend. But there's a big error bar, so it might not be this exact line, but everything else looks kind of steady or all over the place. So we'll continue to keep an eye on Beaver Brook and look for sources as we're able. For chloride, you are probably most familiar with in relation to road salt. So chloride is an ion that's found in both salt and fresh water. Obviously more found in salt water. Chloride ions separate from chloride salts, such as sodium chloride, which is table salt, or some of the other salts that they use for de-icing. In addition to road salt, chlorides can also come from water softeners or wastewater effluent. Some of them chlorinate their effluent to remove any bacteria, although some use UV light treatment to kill that bacteria before discharging their effluent. And then some fertilizers have chlorides in them. Perhaps obviously, concentrations tend to be higher in areas with lots of roads and other places that are treated for ice. And high chloride concentrations in fresh water can stress or kill plants and animals. There's no specific standards in either Vermont or Massachusetts, but the US EPA recommends less than 860 for acute toxicity. So that's the level at which exposure would kill a creature, or 230 for chronic toxicity. So that's the level at which it's a bad idea to exist for long periods of time in that. And as you can see by this graph, the average is about, it doesn't go above 80. So we're definitely below that chronic level. So that's good. But you might see a pretty big bump. And so remember that our first site is upstream of Mount Snow. We sample from one of the Mount Snow parking lots. And then this site is in Dover at the Valley Trailhead. It's downstream of Snow Lake, which is where all the Mount Snow parking lots drain to. And all the roads are around the ski area. And I'm not calling out Mount Snow as being particularly egregious about applying road salt. It's just a fact of ski areas that they need to make them safe for people to drive in the winter when it's snowing. That's their whole thing. And so we do see this increase in chlorides downstream of ski areas and winter recreation areas. And the town itself has a lot of traffic in the winter and is going to be using more salt than maybe somewhere that has less winter traffic. And so you can see this peak downstream of Snow Lake. And then it attenuates, meaning that it kind of evens out as you move downstream and water is coming from other places and maybe has less chloride carrying with it. Looking at wet and dry. This is sometimes something too that we would see diluted in wet weather, and that that seems to be less true in the North Branch of the Deerfield. And maybe that's just because there's a significant amount of salt moving through the system. And when it's raining, it's picking up more salt and bringing that to the river. Beaver Brook looks pretty good. Cold Brook, great. And Ellis Brook, you know, gets a little salty in wet weather sometimes, it looks like. This is looking at the different flow levels. And here you can see what we would expect to see, which is that it dilutes as it gets more water, so that you have the highest concentrations during low flows. But remember that when there's high flows, there's more water at a lower concentration. So it might be moving more. And I don't have those calculations here yet, but I'm working on those for the future. But you see a similar thing. And Ellis Brook looks like has the highest chlorides. So you may have seen also that we have just fewer years for chloride. We were able to include it in 2017, but also it wasn't until 2021 where the state program that we participate in started including chloride as one of their standard parameters. But prior to that, for the full period of this study, we have specific conductance or conductivity data. And so this is a measure of how many ions are dissolved in water. It's a measure of how well it conducts electricity, actually. And it's a general monitoring parameter. So it includes any ions that might be dissolved, but the primary driver tends to be chloride ions, but it can also capture other ions. So different sources could include road salt, just any runoff, but also like local geology affects the base level. If you have a bedrock that dissolves really easily and like metals and things in there, you'll just have a higher natural specific conductance. And part of why we monitor this is it's really easy. It's just a meter, and we can just stick the meter in, get a number. And if there's higher conductivity somewhere that's not reflected by other parameters, we can say, what's going on here? And maybe do some other tests. And then I just have some different numbers for like what numbers will be. And if you're wondering, the difference between specific conductance, which is one harder to say, but it's that it's adjusted for temperature so that you can compare it regardless of the temperature of the water, and conductivity, which is easier to say, is related to a specific temperature. So here you can see the same kind of bump that we saw last time when we started monitoring for this upstream and downstream of Snow Lake. And so this is just showing, this shows, that we're primarily, specific conductance is primarily driven by those chloride ions. So similar thing, but we also have these other years where you can see that the other years were similar. And I would say that within the region of southeastern Vermont, most of the rivers range from about 80 to 200. So this 300 level is actually pretty high for the region. Looking at the different tributaries, for the most part, this is again one that tends to dilute when it rains. That we saw less on the last graph, but these are very similar to the chloride graphs. And you may wonder why there was only dry weather for 2023, and that's because it didn't rain last year. Wait, because I typed the date wrong. It's not 2023 yet. So apologies for that. I don't know how that one snuck by me. But also it barely rained last year. So here you can see this tendency to dilute similar to the chloride, and just the vast difference that this valley trailhead tends to be really high, this site, compared to anywhere else in the watershed that we currently monitor. Maybe increasing trends, once again, big error bars. But that is a lot of upward pointing things. So maybe we're seeing an increase. Maybe there's an increase in salt use. And I didn't show trends for chloride because we only had 2 years of data. So that's not enough data points to really come up with that. So turbidity is a measure of how murky or cloudy water is. Basically clay, silt, any algae, anything that would change the color and of the water. It's measured by scattering light, and you can ignore the Massachusetts standard, but the Vermont standard is 10 for nephometric turbidity units in class A and cold water, and 25 in warm water. So we're cold water, so we're paying attention to that. And you can just see low to high turbidity. Hold on, I'm disappearing into the shadow, so I need to turn my light up. There. So we monitored turbidity in 2017 and 2018 through a state program, and then they discontinued that. And last year, CRC was able to purchase a turbidity meter. So we only just started reincorporating that to our data. But as you can see, and maybe as you know from looking at the North Branch of the Deerfield, it tends to be pretty clear and low turbidity. So that's great. And then, in 2017, I should have taken this out because that was the last year the state included the turbidity in their program, and they were trying to reduce the number. And so they said, only send us samples when it is turbid. So I only sent in a turbid sample. So I should have taken that out, and I apologize. But as you can see, everywhere else also tends to be really good with turbidity. Looking at the different flows, once again, most of our observations are below that line. So great job with turbidity. And in addition to an aesthetic impairment, also, fish and plants fish and other creatures need to see in the water to hunt and gather food. And the plants, of course, need water or need light in order to photosynthesize and create oxygen. So that's why it's important to have low turbidity in waters that are supposed to have low turbidity. So I took out this really high value from the Cold Brook, and you can see these same things, but overall looking good on the turbidity front. I don't know why I left that trend in. This is what happens when you don't have trend data. So here are my conclusions, and then of course I'll open it up for questions. So we have elevated E. coli in downtown Wilmington. That's one of the first things we identified when we started this program in 2017, and we are concerned about it. But we haven't been able to nail down a specific source. Sometimes there seems to be a significant amount of nutrients moving through the system. That is true of many rivers in southeastern Vermont. There's a lot of great fertile glacial soils that like to flow downstream when it rains. And those are loaded with nutrients. That's why they make great farmland lower down in the valley. But we don't want them all flowing away down to Long Island Sound. And then, of course, one of the starkest takeaways is the huge increase in chloride and conductivity downstream of Snow Lake. And then I'd like to open it up for questions and discussion. In addition to questions you may have about the data that I presented, I also want to know what local concerns are for water quality. We don't have too many local community members here, but anyone who's watching the recording, please feel free to email me because I actually live kind of nearby, just over the border in Massachusetts, in Heath, but it's not my home watershed by any means, and so I count on local community members to let me know what their concerns are and where I should be monitoring next. Do you know the sources that I might not know about just from driving or walking by around the watershed? And of course, I'm happy to answer any questions that you have.
Ellis Brook seems to have some problems, at the end of the line there. What's beyond that? And do any of those problems disappear as it gets farther down the lines, say into Massachusetts?
So Ellis Brook is the furthest upstream tributary that we measure, and so and it's not as much water. I think it was putting it in alphabetical order, so it was going Beaver, Cold, Ellis. So yeah, we don't see. It's actually right upstream of the East Dover Road site, which prior to monitoring downstream of Snow Lake was kind of our good upstream site where most of the water quality problems seem to have abated. So we're not seeing a huge influence from Ellis Brook downstream of Ellis Brook because it's not very much water. It's very small.
Okay, good.
I was just wondering if you could easily show us that map and show us.
Oh yeah. Let's see. Hold on. Okay. I feel out of practice with Zoom. So here's the map. And so Ellis Brook is here. Ellis Brook is this light blue watershed. And then, between, it comes in just north of upstream of this East Dover Road site and downstream of the Valley Trail site. And so.
Where's Mount Snow?
Mount Snow's
I
up
see.
here.
I see it up there. Okay, above
See all
Valley
the
Trail.
ski trails.
Yeah.
So is Valley Trail the one that had all the chloride?
Yes. Yeah. So Valley Trail's here. And so you have, you can see the ski trails here and a lot of development in this area. And then the road kind of coming down here. And I was going to look, Ellis Brook has total phosphorus. And so you can actually see that the total phosphorus is high, it's higher concentration. So this is, per liter of water upstream of East Dover Road. So there are other less phosphorus laden waters than, Ellis Brook coming in to the North Branch of the Deerfield. But that's a good question, Jen.
Thank you.
Brian, I had a question.
Yeah.
With chloride, you know, often I've attributed it to high salt on the roads and therefore, right, that's getting directly into our waterways because so many of our roads follow the waterways. But I was just thinking during your presentation that you're monitoring in the summer,
Yeah,
right? But the winter is when the salts are. So are those salts just sort of sitting on the soils
yeah,
next to the brooks and then washing in with rain?
yeah. So I've seen at a conference, I've seen some presentations of of uh, continuous conductivity monitoring, and then they can actually grab samples for chloride and make sure that they can adjust the numbers for chloride versus other ions that those are capturing. But so you can have continuous monitoring where it's taking readings every half an hour, every hour over a period of time. And they were thinking, they left them in for the winter, and we see even higher levels of chloride in the winter, but you still see pulses of chloride moving during rainstorms. So it's very clearly, it's in the soils, it's still on the roadside. And then every time it rains, it just adds a little more. So, this watershed would be a great candidate. I don't currently have any conductivity loggers, but it's definitely something we're looking into. In the Deerfield watershed as a whole, there's a lot of concern on the main stem, although the conductivity of the main stem in Massachusetts is much, much lower than the North Branch, but just a lot of concern about all these roads that are right along the rivers and how much salt really get dumped on them. And so that is something that, as time and funding allow, we're hoping to investigate. But this would definitely be a good candidate to look at what are the levels in the winter, because I bet this is like you said, it's the summer. So how high do they get in the winter?
With E. coli and nitrogen, are you getting any closer to pinpointing any specific problems with specific wastewater treatment plants or agricultural areas or places where there might be a lot of failing septic systems?
So I have been in touch with the Wilmington wastewater treatment plant, and they are extending their line up Route 9 to get more households on sewer instead of septic. And they actually used our data as argument for why it needs more funding to extend those sewer lines and get off of septic. But no, they're very hard. E. coli in particular is very tricky to track down. It tends to change drastically from year to year, seemingly with no reason. And then I do think that some of the E. coli and phosphorus, I think at some point could perhaps unsurprisingly be attributed to beavers on Beaver Brook. So that's harder to track down over time, but it seems like Beaver Brook is not, the source is not on Beaver Brook alone. There's multiple sources contributing. There's a lot of cows and hay fields between the East Dover Road site and the center of Wilmington. There's a lot of pavement, and there's probably some old leaky pipes. So there's a variety of potential sources, and it's probably a combination of things, and not just, as much as I would love to one day find, a source that solves an E. coli problem. It tends to be very complex.
Well, I find that fascinating that Wilmington was using your data as rationale for extending the main collection lines farther up the valley. And that's something to mention, even if we don't specifically use the name of the town, but that how this data can be used for benefit.
Yeah, they knew it's something that they wanted to do, and they just were able to say, hey, this is something that should be funded this year because, we have these high bacteria levels and we might be able to help. And so maybe we'll see that improve also.
Well, be sure to mention that in any of these reports or on the website or whatever, because there's a lot of concern about monitoring for monitoring's sake. But if you actually use that monitoring
Well,
data to accomplish something, that's a great thing.
and I should have added, I did like vaguely mention that we participate in a state program. So the nitrogen, phosphorus, and chloride data is part of the La Rosa Partnership Program, which is funded by the state of Vermont and the Agency of Natural Resources. And we work with our watershed planner, Marie Caduto, to select sites. And then those get uploaded into the state database. They're used in the Vermont watershed tactical basin plans. And I should shout out that the Deerfield's turn is coming up. And so she will be working on a new tactical basin plan that will identify areas in need of restoration, but also areas that are of very high quality, and other important things. And that helps drive funding to different watersheds and different projects. So this data, our Deerfield watershed straddles the states, and Vermont is definitely the more supportive state of using our data. Although Massachusetts has opened up avenues in recent years of accepting our data, but we mostly only monitor for bacteria in Massachusetts because of that.
I have another question, Ray, and you kind of just mentioned the phosphorus along the Beaver Brook. And I'm not as familiar with the Beaver Brook in that region. And I'm just wondering, from those of you that are more familiar with it, like, I'm just wondering, are there high erosion spots along the river? You know, is that putting more sediment into the water? You know, I know some of our other rivers see that, you know, every time it rains hard and then more sediment gets in. So I just don't know if that brook has that along it.
I don't know that it does. It does have a couple of buildings where they have horses very close to the stream that I've inquired about before. But I'm not sure that it has that much in terms of erosion. But there is this contributor called Spruce, I think it's Spruce Pond. It's a man-made pond. We tried to study it, but it has so little outflow that in the summer it completely stops. So, you know, there's all sorts of houses and camps around there. I don't know what their septic systems are like and how well they work, but you know, we tried to study that, but Ryan, it seemed almost impossible to do that.
That was that tributary that was there, but yeah, it was very hard to monitor for, but Jack tried.
Well, one of the store owners downtown, I guess, got someone's attention.
Yes.
And they decided to do it, but it just, you know, it just wasn't possible. But that could be an intermittent cause. These horses could be another one. And further up on Beaver Brook, there is an increasing livestock group that's right on one of the tributaries, and their cows go right down into the stream. I talked to Corey Ross about this and brought this to his attention, and he's working with the landowner to try to correct this. But I think it will be interesting to see what this new septic line for the town, you know, does to this, because that's certainly been an area of concern.
Yeah, Margot, Beaver Brook, you know, as you're coming down the mountain into Wilmington, is the one that's right along the Route 9. And it's a pretty steep gradient, but you know, especially compared to the neighboring green, you know, or the whetstone, there's not similar erosion from there. But.
So I'm sorry I came late. Today's been a crazy day. I had something that I just couldn't get off, but I'd like to learn, maybe you covered this about chloride. Does chloride come with the sodium chloride? Is that what chloride
or
comes from?
There's a couple of other chloride salts that they use to de-ice roads, but I think they primarily use sodium.
Because my understanding is that there's some new techniques to use less sodium And I'm told that Wilmington tries to use this. I don't know whether they do or don't, but there are some ways to have less sodium and still be efficacious with avoiding problems with roads.
Yeah, a thing just popped into my head too, Margot, about your question before about summer chloride levels, and that is that they use a chloride spray to keep dust down
Yeah.
on some dirt roads. So that is also another contributor. But I also see that Kevin has a question. You're muted, Kevin.
I'm always concerning Ellis Brook. I'm pretty familiar with it. It's only half a dozen miles from me, and as it drains out of the mountains and crosses Dover Road, Dorsetch Road, onto the East Dover Road, upstream, and be testing at that point, at that intersection, before it gets to the waste treatment plant, because it just doesn't make sense for a mountain stream to be that bad. And I just thought that would help pinpoint it, if you did it before, where it goes in and where it comes out of that region. And concerning the E. coli bacteria in Wilmington, goodness, I think maybe 3 or 4 months ago, not much more, if the Wheeler farm sold off all their cows. That was the major farm on Route 100 that borders North Branch there. I mean, you could be looking at upwards of 200 less cows going in. So I think you might maybe see a difference with the testing, with the absence of all those animals.
That would be very interesting. I think,
Yeah.
If at all possible, we should try to do that.
Yeah, we have the sites for this summer, and yeah, we'll be doing E. coli, from, obviously we don't test the bacteria in the tiny trickle through the Mount Snow parking lot, but from the Valley Trail down to the center of Wilmington. And yeah, I think, we had that mountain marketplace site for a while. In the first year, the E. coli was actually higher there. And then for 2 years, it was lower there. So it will be interesting to see what impact those cows may have been having on the bacteria and the phosphorus levels, and the nitrogen that, they generate all of those things.
Well, Ryan, they may have had cows, but they may have been doing different things with cows during those periods of time too.
Exactly.
In terms of their proximity to the stream.
Exactly. Yeah, so that's great to know. And yeah, we'll definitely have to look for the effects this summer.
Are they planning to buy more, Kevin?
I do not believe so. I think it was just one of the federal initiative buyouts, and another farm goes. It was one of the few places in the area where you could see cows grazing while you drive.
Okay. So Ryan, one of the things that I've always wondered about, but I have not looked into this, is how do you identify point sources of where, E. coli in particular is coming in? And I don't know, it seemed to me that if you focused, more intense efforts, not all the time, but for a period of time, you could depending on how you manage the weather, and if you had the right team of people to do the sampling and all the funding that you need, maybe you could find a point source. I don't know whether this is crazy, but it seems to me that that would be one way to help identify some of the things that Margot was asking about in Beaver Brook in terms of where this is coming from.
Yeah, so I think you remember, I think it was in 2018, Kathy Erfer, our Vermont River Steward, and I got a grant to do some extra work along the Beaver Brook, and we had a public meeting.
Yeah.
But also we did a stream walk of kind of the lower portion of Beaver Brook to look like get out and look for point sources. And certainly nothing in that lower portion, but that public meeting did really connect us with a few more of the community, and got a little bit more of the history. And you certainly could do less frequent, more intensive bacteria monitoring. And like you said, you would want to chase specific weather conditions.
Yep.
And that is possible. One of the tricky things that I've had with, and that we call that source tracking. One of the tricks of source tracking is whenever I seem to get a grant to do source tracking, it's a drought. And then you don't have the
Oh,
wet weather
yeah.
and there's no E. coli. So,
Right.
that's an area that is, I would like to have more time and more funding to do. In Beaver Brook, I have a couple of hotspots in the watersheds that I monitor, and Beaver Brook and the Wilmington downtown area is one of them that I try to write into grants. And then we also have sometimes borrow from the EPA a toolkit full of meters that measures for chloride, ammonia, and a couple other things. Oh, surfactants, which is soap, the presence of soap. So that helps kind of track down illicit discharges. So those would be like household or industrial waste discharges. They don't tend to, that kit doesn't tend to detect agricultural runoff as much, but it could. So there's a couple of options, and Beaver Brook's on my list, and I know you'd be willing to help Jack collect some samples.
Yeah.
But the bacteria sampling it's relatively affordable, but it is kind of expensive compared to some of the other tests. It's about $16 per sample, and so if you're doing a bunch of tests, the price can add up. But in a perfect world,
Yeah.
I would do
Yeah.
more.
Well, we
But
don't
Beaver
get-
Brook's definitely on my list.
So one of the other questions I had for Beaver Brook and for Kevin on the North Branch is as I drive along there very frequently, as I do, I'm always sort of wondering about, planting trees along these areas. And if you tell me, Kevin, now that they're not having, cows in these fields, there are some areas, where the farm is, that they've removed the cattle, it would benefit that. But that's just one small area. But there are quite a number of other areas that, I think would benefit, from tree planting. But I'm no expert in that. It seems to me that would be something maybe Marie would know about or would be interested
Yeah.
in. But there's
So-
a lot that could be done, I think.
Trees would definitely help. And we actually did like this past year, CRC did an outreach by mail to different landowners that could benefit from tree plantings. It's really dependent on a willing landowner. The funding for trees for streams. I mean, there's a whole grant program in Vermont called Trees for Streams. But
Yeah.
there's a lot. Vermont really prioritizes clean water, and so if we have willing landowners, CRC can definitely find them trees. I know that when I started the program in the Deerfield, I drove around with Marie, and she showed me, and she told me everything. And there's a couple properties that have had trees planted, and I think there's one that had trees planted and then they got cut down because they couldn't see the river anymore. And some of the landowners, especially if you hay your field and you want every little bit of hay, we just haven't had the willing landowners. But if you have community connections, if you know those landowners and say, hey, we know where you can get some trees, especially if you're experiencing erosion, that will help with that. And you're not losing your land into the river. The trees will help with that. So we would love me, Margot, Corey would all love to plant trees in this watershed.
Well,
I hope I can say that for you, Margot.
Well, you can say that for me, and then I will gladly pass them along to you and the Conservation District, because you both do such a wonderful job with planting these buffer areas. And so, yes, that area that you were talking about, Jack, is sort of been a high priority area for getting buffers for quite some time. But as Ryan mentioned, it takes a willing landowner. And so the more connections that are within the community that know some of those landowners and might be able to talk to them and connect them with the resources, it's very helpful.
Well, sometimes if they hear things are going well and have gone well from their neighbors and others, they're willing to do this. My understanding is that the dam on Beaver Brook is going to come out, and there's going to be tree planting after that. So if that went, perfectly smoothly, I mean, that would be good information that could be used for others. The other thought that I had is, Kevin, I didn't know that Rob Wheeler had sold all his cows, but he has a very important business with his sugaring. And I know that maybe sugar maples are not right next to streams, but red maples are, but maybe a little further back. Maybe he could be induced if there could be some sugar maples not too far, but still effective. And that's a big piece of land that he has all along there. And a lot of it's in just, blaring sunlight. Maybe this is an opportune time. And Ryan, you said you had sent something out, but if the situation changes like it has apparently for the Wheeler farm, maybe they would take a new look at this. I mean, I sort of know him. I'm not best buddies with him, but he knows who I am, and I'd be willing to try. I don't promise anything, but maybe things have changed enough to give it the old college try. Kevin?
Yeah, I agree, Jack. Looking at that field, there's places where the stream bank is just clear cut right down to the river. And I think, as Margot mentioned, that some of these fields are so small that putting in a 50-foot riparian buffer would take a substantial amount of grazing away from livestock. I think that would be true, especially up at the horse stables that are further up Route 100, up at the roadhouse. And when Adam's farm had animals, they were grazing within feet of the river. Those animals are now gone too, but that whole stretch is in desperate need of riparian help, just to stabilize the stream bank and to do the filtering. Absolutely.
I'm always
The
amazed
biggest
at how many.
challenge.
I'm always amazed at how many bass you can catch up in that beautiful stream that should be having brook trout.
Yeah.
Well, I want to be conscious of the time because it's now quarter past when the program was supposed to go. And this has been a really interesting discussion, and you all have brought to light several issues that I think are, some of the water quality partners will be very interested in following up on. But if, after today, one, please feel free to, when I get the recording up, we will send it out, and please share it with any colleagues or people that that might be interested in watching the recording. And Jack, you can see the part that you missed. Good. And then, if anything else comes to mind, please, Brian, just put in the chat his contact information. He would love to hear from you. Some of you know Corey Ross at the Conservation District, the Windham County Conservation District. He also has been doing some work in this area and would be interested in hearing from you also. So thank you all for coming, and we really appreciate you taking the time to learn about sort of the history, the water quality results that have been coming out of all the sampling that volunteers have been doing under the DRWA. And, you know, please continue to help support the DRWA to continue the monitoring. It really does make a difference in being able to look at trends and figure out the health of our waters. So thank you all again. Jack, do you have one?
I just have one last, maybe you realize this or we're going to do this, but I think you definitely ought to contact Scott Tucker, who's the town manager. He takes a real interest in this, and I think he'd probably look at this video with the data and the discussion, and you know, he's a guy that can do something, you know, probably more than some of us.
Well, thank you, Jack, for that suggestion. I do know that there are some people who are associated with some of the towns that are unable to be here tonight that want to see it. So,
But he's the town manager.
yes. But so, you know, again, just help spread the word, and thank you all for coming again. It's been a great discussion this evening.
Thank you, Ryan. Thank you,
Thank-
Margot.
Thank you.
Thanks.